Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. We're a meetup group in Brisbane and we do online and in-person sessions this most weeks, and next week will be our next in-person session at Amazon Web Services venue in Brisbane City. So I'd love to see you come along, and we've got some good presentations there. But tonight we'll be doing really a session for absolute beginners. So you've never seen Python before, and it's really just to get you started. It's an online session and it's live, so it's you can ask questions. You can ask them on the YouTube chat or in Slack. The Slack ones tend to get through a bit more reliably, so just in this learning to code section you can send through your questions and I'll try to answer them during the presentation. And that's really the biggest hurdle in Python is really just getting started. So obviously sometimes it's just some small little thing, but it seems a big thing at the time. So feel free to ask any sort of question. This is designed for absolute beginners. Now I've created a script for tonight's session and I've given a link. So the link is, if you look below this YouTube video you're watching, there'll be a Colab link, and also in Meetup, if you've registered there, you can select the link. So I'm going to click on the link here, colab.research.google.com, and that's going to create a new Colab notebook for me, just based on the one that I've prepared. Now see, it'll say here changes will not be saved. That's because it's still currently in my area and you don't have permission to make changes. So what I recommend you do is copy it to your own drive. So you just click this button here that says copy to drive, and that'll create a copy in your account, and you'll be able to make changes to it, and you'll be able to save those changes. You'll be able to come back at a later stage. Alright, now I'm just going to close these release notes on the right. Okay, so I'm going to share this one as well, so you'll get any changes that I've made during tonight's session. So I'll just share it, and anyone with the link can have a look at it. There'll be just a viewer. Copy the link, and I'll share that on Slack, and I'll share it on YouTube chat. Okay. Right, so this is running in Google Colab. It's a fantastic service that Google gives us for free that allows us to run Python programs. And it's interactive Python, so it's actually more, it's a better learning environment than just normal Python, but can do just about everything that normal Python can do. So yeah, I'd really recommend starting to learn Python in Google Colab and then moving on to Python, just scripted Python on your own computer at a later stage. So I've given you some links here. Obviously this is the one that you're in, that you've copied. There's your YouTube link, there's the Meetup link, but I've also got our GitHub site, and we've got all our past sessions there. So if you go to that, you'll find these old Colab notebooks and Python scripts from other old sessions that we've done, and they'll all have the YouTube links in them and the Colab links. And actually most of the ones I do on GitHub, I actually convert them from a Colab notebook to just a straight Python script, so you can see there's slight differences between the two ways of running it. Okay, so installing the software, we're using Colab, so you don't need to. I should stop double clicking. We're using Colab, so you don't need to install it. But if you do want to install Python for other Python work, I like to get it from python.org. Some people like Anaconda. Anaconda comes with a lot of third-party libraries, and Python from python.org is a lot more streamlined and just lean, and you just add what you want to it. So that's the one I prefer, but a lot of people use Anaconda, and that's fine too. It's also good to have an IDE. It's easier to write programs. My favorite is PyCharm Community Edition from JetBrains. Other people like using Visual Studio Code, which is just getting better and better all the time too. Okay, now there are different ways to write Python. So what we're doing here is IPython, interactive Python in a notebook, and it is also just scripted Python. So I'll show you some of the differences. Now this is Google Colab. It's got a bunch of cells. So if I select that, you see it's got a rectangle around it. That's called a cell. And these cells can be either text, formatted text. So I've got like a bit of a headline here and some text down here in an unordered list. And then we've got code cells. And at any time I can create new code cells or new text cells. And the code cells are where you type in your Python code. So this is an example of some Python code. And it's really showing you how to do comments in Python. Comments are lines of code that don't do anything. They really just are there for you to read, and by reading them you can work out what the code is trying to do. So they're like messages to your future self or messages to other programmers of what you've tried to do in a particular place. So this message here is telling you what to do. It's telling you how to bring up the IPython help, and it's by typing a question mark. So I'm going to get rid of the comment, the hash symbol there, so that I've just got a question mark on itself. So that's no longer a comment because it's not got the hash in front of it. And now if I run this cell just by clicking on the triangle, it'll run this command, which is question mark, and the question mark is an IPython specific thing to say bring me up some help. Now the very first time you click run, it's going to be pretty slow because it's Google are giving us some RAM and some disk space. Anyway, that's happened, and here's our help. It tells us all about IPython. So I'm not going to spend too much time on that. I'm just telling you where you can get help. Alright, so let's move down to the next cell, and we're going to explain. So this is an example of a typical Python command. We're going to add two numbers 5 and 3, get the result, and print it. So if I run this code, remember there's 3 comment lines and 1 non-comment line. It's just going to run that non-comment line and print the result of 5 plus 3. And you see here there's our result that we got, which is 8. Now that'll work in Python as well as IPython. In IPython there's something we can make it even easier. We don't even need to put the print command in. If it's on the last line that's being executed, IPython will just display the result of any last line. So we just type 4 plus 5 on a line, and we get 9 as the result. So we could use Colab as just a calculator if we want. If you have several commands, they're just executed sequentially. So each one's on its own line, and Python just goes through the line. So comment, print 4, print 3. So it runs those 3 commands, and we see the 4 and the 3 have displayed. Okay, got a little message there from not you, not me. Hello to my Python peeps. Fantastic. Okay, so let's try doing that with our IPython way of doing it, where we just put a 2 and a 1, and so that's the results of each of those lines, but we only get the last line. So you have to do a separate cell for each line that you want a result from if you want to display results that way in IPython. So it's no big deal, but just be aware of it. Okay, so now let's have a look at, tonight we're going to be looking at functions. So first of all, let's look at a mathematical function. So if you're doing your maths and you know about functions, there's your quadratic function. it just says x squared minus 4x plus 4, and we're going to calculate that and store the result in a variable called y, and we're going to calculate it based on a variable x that's got the value 3. So we'll put 3 into the value x, calculate x squared minus 4x plus 4, and put that value in y, and then we'll print out the result. And there we've got x equals 3, y equals 1. So I've printed it. I'm using f strings here, and I've done a whole sessions on f strings. It's not really the focus of tonight's session, but if you want to know more about f strings, you can, but basically you can just ask. But basically it's just anything in curly braces gets evaluated and displayed, and here I've used the equals sign, so I can say x equals and it'll display x equals and then the value of x after it. So it's just a quick way of getting a quite nicely formatted output. Okay, we can calculate y for different values of x and put all the x and y values into lists. Okay, so I've written some code here. We've got a list, so this these lines here are indented 4 spaces, and if you're using Colab straight, so Python traditionally the number of spaces to indent by is 4, and so I've actually changed the setting in Colab to change it from 2 to 4. But if you're typing in code, you might find it's just indenting 2, and that'll work as well. So you don't have to indent by 4, you can just indent by 2, but I've left it at 4 so that it looks more familiar to compared to other Python code you might come across. So anything that's indented is what's called a code block. You normally start a code block with a colon, and so everything in there from there on is part of the code block, and that'll be the loop. So we're going to have I is going in range 41, which means it's going to start at 0, 1, 2, 3, 4, 5, all the way up to 40, and not including 41. Then I've got another code block down here, see another colon, and further indentation, and I'm just going to print, do some print commands when I is less than 10, but I don't want to print all the way up to 40, so I'll just put a conditional in there, say just give me the first 10, and print them out, and then after that just show me what's in the full list. Okay, so what I'm doing, I'm storing I divided by 10 into x, I'm storing x squared minus 4x plus 4 into y, and getting all my x and y values, and here they are stored into lists. You can see a list has got these square brackets and lots of values all separated by commas. So we can plot that. First of all, we'll import this third-party library that Colab's got installed for us already, called Plotly, and then we'll just plot it in on a chart. And there's our quadratic equation. And we can actually look at individual values just by hovering over it as we go. It's quite a fully functional charting package here. It does a lot of JavaScript. I can zoom in, I can pan, move it around. Okay, reset my axes. Alright. So let's have a look at what we've done here. We've calculated this formula every time in a loop, but it's a bit cumbersome having to type in this formula every time we want to use it, and it's likely to be error prone. You know, sometimes we'll get it right, sometimes we might accidentally put a mistake in the code. So you're better off to define a function and just call that function whenever you need to have that function calculated. There's only one place in that code, but we have used it in several places already tonight, so it would have been better if we'd had defined in a function. So this is how you define a function in Python. You start with def, which is a keyword in Python to say I want to define a function. You give the function a name, f, and then in parentheses you put any arguments that you might want to put. We're just going to have one, we'll call it a, and then the function is in the code block, so it's indented, and we're just going to return a squared minus 4a plus 4. So if I run this cell, it doesn't do anything except define the function. Now the function's defined, I can call it whenever I want. And remember, the function's name is f. So to call the function, we just use the function's name. Then we put in parentheses the value, or put parentheses after the function name that says I'm going to call it. And then we're going to put the arguments inside the parentheses if there are any. So let's call this function. And there we go, the result is 9. So I've got a task here for you. See how you go at this. Call the function using an argument of 2.5. So it's a pretty easy task. I've given you an empty cell here you can type into that. So all you need to do is, I'm going to now answer it for you. So you could pause the video if you don't want a spoiler. Put in the function name, then open parentheses to say I'm going to call a function, and then put in the value of the argument that you want to call a function with, and run the cell, which by clicking the triangle, and you get the result of 0.25. Okay. Now I've provided a solution here as well, which is doing the same thing but storing the result in a variable, and even passing the argument in a variable rather than as a constant. There we go, and that printed the result using an f string. So f of 2.5 equals 0.25. So Python's a dynamically typed language. So we can call our function with any data type that understands the asterisk, dash, and plus operators. Because if you remember our function, we've got an asterisk in it, we've got a dash in it, and we've got a plus in it. So that's for integers, and floating point numbers, they're just multiply, subtract, and add. So let's run the function passing in the value 3 as an integer, and then we'll run the function passing in the value 3 as a floating point number. So in Python we designate a floating point number by putting a decimal point after the number, and it could have a decimal fractional part after the decimal point as well. And then we'll run it, and then I'm going to display what the type of x is, what the type of y, which is the result of the function, and what the value is. So let's run this. And see, the first one we passed in an integer, and the result was an integer. We passed in 3, and the result was 1. Now if we pass in a floating point number, 3.0, then the result will be 1.0, and we can see that the number that we passed in was of type float, and the number that got returned back was also of type float. Now you see, when you're writing code and you're writing repetitive code, that's always a good sign that you should be using a function. So here's a bit of repetitive code. That's a little bit complicated. You probably don't understand what it all means. Pulling out these name attributes of the type to make it look a bit nicer. It's got a bit of formatting in there, 7 characters wide string, 7 characters wide string. So we could put all this into a function, and then we wouldn't have to type in these long lines each time. So let's create a function to make printing the return value and type easier, and this is it. So if I just put all that into a function, and this is interesting here. One of the arguments to the function is not a value, it's actually another function. So we're calling it fun. It could be called anything, and we can pass a function into this function, and then we can call it by putting these parentheses after the name, fun, and then parentheses, and then putting in the value. So what we had up here, we can redo like this, and that was a bit easier to read, although it's a bit of a black box. You don't know what's going on inside print function result, but I don't think that's going to help a lot of people, so it's okay to be a black box. Alright, try calling the function with an argument of a different type, for example decimal, and you can import decimal. So let's import the decimals, which is a standard library, so you don't that comes with your standard python.org installation. You don't need anything else, but it's not a built-in function. You have to import it. Alright, and now we want to call the function. So let's do the same thing, print function result, and the function is going to be f, and we're going the parameter is going to be decimal dot decimal 1.1. There we go. So we've sent in a type decimal. It's calculated it, because decimal understands all those operators, plus, times, minus. It can return another decimal, and the value that it returns is 0.81. So that's pretty useful. It's very flexible that our function can do that without us having to know that decimal even exists. And there's other classes as well that we could use that would still work, like complex. We could have variables of type complex. We didn't need to know that that exists, and yet our function would still work. So let's check our solution here and compare the result of doing decimal 1.1 and a floating point number 1.1. And you can see I'm referring to decimal slightly differently this time. The first time I imported the whole library by importing decimal, and then to use the decimal class inside that library, I had to refer to it as decimal.decimal, and then give it the value that I wanted. In this case, I'm just importing the decimal class out of that library, and so now I only have to use that name when I'm defining an object, a new object of that class. But this is where it gets interesting. Our function calculated 0.809999 using floating point numbers, but decimal it calculated 0.81, which was exactly right. And that's because the Python floating point data type tries to represent floating point numbers as binary, and there's a lot of floating point numbers that don't convert exactly to binary, so you get what's called a floating point error. So the errors are very, very small, and you wouldn't notice it. Like even if you formatted this to 10 decimal places, you wouldn't see it. But because it's got all those decimal places out there, you're now seeing it. And so that's where you'd use the decimal type, because it will always be exactly right. It's slower, but it will be exactly right. So you tend to use decimal for accounting type applications, and floating point for scientific calculations, because the scientific ones are more complicated, but it's much faster using float, but there will be those floating point errors that you just have to be aware of. Okay, task 3. Rewrite our loop from before, which created list X and list Y, but this time calling the function. Okay, so when it says rewrite, I would normally just copy and paste. So I'm going to scroll back up to our loop. And copy that. And here, rather than typing in explicitly the function, we'll just call the function f of x and run that. So that gave us the same results. You can see here the floating point errors that can creep in. All right. And now here's a solution that's been provided. So this solution is using a thing called list comprehension. Because this sort of thing is so common, you create a list, you have a for loop to populate it, and you append in values, and then you print it. But having the for loop to populate your list is so common that they've created a syntax to do it all in one line. So we have our loop for I in range 41, and we have the value we want put in the list, which is I over 10, and that all goes into list X. And let's run it just to make sure that we get the right results. It does give us the right results. And similarly for list of Y values, we have our loop, and we call our function with the parameter I divided by 10. And one of the reasons I've had to do I divided by 10 here is because range will only give you integer steps in your loop. So I only go up in integers, so if I want to go up in 0.1 of each time, then I go up in integers and divide by 10 to get the 0.1 steps. And by doing it that way, you actually alleviate some floating point errors. Alright, so what are we on to here? Built-in functions are just like functions we create. They're called by entering their name followed by parentheses, which we're used to, and any arguments need to be included in the parentheses. So print is a function that we've been using. It's just got a name and parentheses to call it. So if I run that, it'll just print a blank line to the console, which is a bit hard to see. We could put in a bit of text in there in quotes, and it'll print that to the console. So what other built-in functions have we already used? So this is where I'm asking you to go back through all the code that we've just been through and see what you can find which are functions. So I've gone through and found a few. So we use the range function. So with one argument, it's the argument is the stop value, and it'll go up to, starting from 0 up to, but not including that stop value. So remember, we used them in our for loops. Type, we used that when we were printing results to see what type of data came back out. So we put a value in and called in type, and that would return the type of that value. px.line, that was a function. It had 2 arguments in it. It wasn't a built-in function because it came from a third-party library, so we need to import that. And we're calling this function in a different way to the way we call these other functions. And this one's using named arguments. So we say, we're calling the function, we want x to be equal to this and y to be equal to that. And you can do that with your functions as well. Like when you've got a named argument, you can specify which one it is. And the advantage of that is that you can then put the values in whatever order you like, and you know that the values will be assigned to the correct variables or parameters. We call decimal and the value as a string, but that's not really a function, that's a class. And I can't really tell just by looking at it that it's a class, although the convention is that classes will use title case and function names will use lowercase with underscores. And so whenever you're writing functions, try to use a naming convention, lowercase with underscores, and if you're writing classes, try to use title case on the class, and that'll help other people identify whether you're calling functions or classes. But those rules aren't followed 100%, especially some of the old things in Python that have been around since year dot don't follow that convention closely. All right, so functions so far that we've created have had arguments, but we can create a function that doesn't have an argument. Say we want a function that always printed the current time. So it doesn't need an argument, so we can just leave the arguments blank and just print the current time. So every time we run show time, it'll show what the current time is. So if I run it again, you can see it's gradually incrementing the time. And the time must be in UTC, Universal Coordinated Time, because it's now showing 8 o'clock in the morning. And that's whatever time it is on Google server. Functions can return values, as we've seen. So I'm going to create a function here called time zone regions. I'm going to find all the time zones, and then just extract the regions from them. And I'm going to use this third-party library called PyTZ. So it's not a standard Python library, very, very popular. But these days, they actually recommend to use dateutil.timezone over PyTimezone. For this case, dateutil.timezone doesn't give us a list of time zones, and for demonstrating, one of the hardest things is finding useful data, so I'm going to use PyTimezone. Right, so let's run it. What it's going to do, it's going to create a set. It's going to look through all the time zones in this that gets returned with pytimezone.alltimezones, and then split them up. If they've got a slash in them, then it's going to be a region and a zone within that region. Otherwise, it might not have a zone within a region, in which case the full name is the region. So I'm going to look for a slash. If it's got a slash, I'll just take the name up to that time. Otherwise, I'll just take the full name and I'll add it into this set. And the thing about sets is they have unique elements in them. So if I've already added it once, it won't add it again. And that way I'll get a unique list of all the regions, and I'll just then sort them and return that as the function. So here are the regions that came out: Africa, America, Antarctica, Arctic, Asia. Alright, so let's have a look at how it got that. So let's say for tz in pytz.all time zones, so this is what they look like. So you can see some of them have got a region and then a zone within the region, and other ones like Cuba, it's just got the region and they don't split it up within the region. So Australia's got a whole bunch, Asia's got a whole bunch. Alright, so you can see why I have to search on that slash sign to know whether it's going to be split up or not. Okay, task 5. Define a function which takes one argument, the region, and returns the time zones in that region. Okay. So, Zach's asked, can you help me to code, which is what we're doing here. So if you ask a specific question about where you're having problems, but you can just type along following me if you want. So we're going to create a function. So we define a function, def, it defines the function, and we'll give it a name. It's going to be time zones for region. Okay, and we'll give it a region as the argument, and we're going to return all the time zones in that region. So we'll create an empty list. Yeah, that'll be go list of zones, and for time zone in pytz.all time zones. Now we just check if it's in the right region. So I'll just do a simple check here. I'll just say if time zone dot starts with region, then we'll append it to the list. Okay, so let's check this out for Australia. And here we go, we've got all the regions that are in Australia. So that looks pretty good. Let's try New Zealand. So New Zealand, there's a time zone called New Zealand Chat, whichever that is, and it starts with New Zealand. So our test here didn't really distinguish those two regions, and then neither of them got separate zones. So we haven't done quite as well as we could have. Okay, Zach wants me to come to the exam. I'll just say practice makes perfect, so just keep doing lots of coding and you'll just get better at it. Alright, so let's look at the solution. Solution's a lot longer, but it's probably not a lot more lines of code, and it's actually rewriting the original code that we had. So remember we had time zone regions, which was quite a few lines of code, and now we've got time zones for region. So both of those functions are quite short. In fact, both of them only got one line in them. And then we've created this new function called region for time zone that will check to see, well, it'll just work out what the region is for a time zone. And so that'll do all the logic that we need about whether there's a slash sign or not in it. So we can write this one function here, and then we can call it from both of our other functions. So this should solve the New Zealand and New Zealand chat problem, because the region for time zone here will come up as New Zealand chat, and of course that won't match New Zealand, so that will work. So let's have a look at running this. There's the results. So there's our Australian ones, there's our New Zealand ones, there's our ETC ones, and there's our Universal Coordinated Time one. And we've even got one that returns all the regions. That replaces our original function we did before. So that looks good. And then here we called the help function on region for time zone, which is what we've just written. So we wrote region for time zone here, and you see the first line of this function we put in a multi-line string. So in Python you can do a multi-line string by starting with triple double quotes or triple single quotes, and in this string we put an explanation about what the function does and an example. And now if someone calls help on our function, they actually get this quite useful bit of information. It says the function name and the argument, and then what it does, extracts the region from a time zone, and then a bit of a description about it. So these are called doc strings, and I try to put doc strings in my functions whenever I can. So I recommend when you're writing functions to always stick a doc string in there, and then you can put in you can always call help on your functions, and even in your IDE like PyCharm you can just hover over the function name. See if I hover over the function name, let's see if it does it. There we go. Even in Colab it's using the doc string to return some help about that function, so that's pretty helpful. Zach says, how many days will it take to learn Python? Yeah, so I like to have some sort of project, and that's a good way of learning a language, because then it really forces you to solve problems. So projects can be anything. One of the most fun ways of learning Python for me is actually using Raspberry Pis, because you can connect them up to little electronics and make lights come on and off. And so you can write quite simple programs, but it's teaching you the structure of the program, and you can see some physical results from what you're doing. But you know, any project is a project. I hadn't done any Django apps before, and I had to write a registration app for next week's event at AWS, and so I said, right, that's going to be my project. So I sat down and with Django, worked through the tutorials, but using my particular project as my test case, and I learnt quite a lot of Django that way. Alright, be careful when using the ETC time zones. I'm just putting this in because I find them a bit confusing. So for example, ETC plus 10, when you display that time, it shows minus 10 here. So Brisbane is actually 10 hours ahead of UTC. But if you wanted to put in an equivalent time zone for Brisbane, you would put in GMT minus 10. So it's basically saying Brisbane minus 10 hours will give you GMT. So anyway, just be careful of that. That's a trap for young players. Help can be called on built-in functions as well as your own ones. So for example, this is a doc string that the Python people have put in the print function when they created it. Okay, arguments to functions can have default values. Oh yeah, so that's looking at the print function. We've got default values here. So separator equals a space, end character equals a new line, file output it's going to go to sys.standout, which is your standard out to the console, and flush equals false. So they're the defaults, but you can change any one of those just by applying that name, just like we did in Plotly. Calling that function, we used named arguments there, so you can do the same in print. So let's do a function here that's going to calculate the total number of seconds when we provide the minutes and the seconds, and we'll also set minutes and seconds both to default of 0, so that we don't even need to supply them if we don't want to. So we specify the named arguments just like we did before, and then we put equals and the default value in, and it's best if that's an immutable value, but anyway, that's a bit more advanced, so we won't worry about that for now. And then the number of minutes, yeah, that's describing what it is, and we just return minutes times 60 plus seconds to give us the total number of seconds. So if we have 32 minutes and 15 seconds, that comes up as 1935. So there we've called the arguments by order. So we've just passed the numbers in a particular order, and it's just assigned them in the order that they were provided. Here we've provided them by names, and actually in the wrong order. And it still worked, 1935, because we put the names in there. So that's why I often say it's a good idea to provide names when there's more than one argument, so that it doesn't matter if you get the order wrong, it'll still use them in the correct way. And it's really easy to read that code and see if you've put the values in the wrong values in. And you can mix and match, so you can you have to do the ones you're calling by order first and then the name second. So in this case, once we've used up one of our two arguments, there's only one place for the second argument to go, so it doesn't really display it. But anyway, we'll move on to task 6, which is expand total seconds to take 3 arguments, hours, minutes and seconds, and do the same thing. Well, it's so similar, I'm not going to bother typing it out. All we put in here, hours equals 0, minutes equals 0, seconds equals 0. So our ones from before, like this line, will still work. The other ones won't work because we've added a new argument in. So once again, another reason to use named arguments, just in case the developer decides to put a new argument at the beginning. And as a developer, I'd recommend not changing the order of the arguments if something's out in the wild and being used by other people. Okay, so let's have a look at these examples. Calling by order, that gives us the same value as before. Calling by name, and you see now we don't have to even provide the hours because it's got a default value, so we just provide the seconds and the minutes, and that works. If we do want to do anything by order, we have to provide that first parameter, which is hours, but we can supply them by name in any order, as we can see. Okay, define a function which converts temperature in Celsius to Fahrenheit. Well, that's a fairly simple function, so let's just call it C, return C times 1.8 plus 32, and let's call that Fahrenheit for 100 degrees C should be 212 degrees Fahrenheit, and then that's correct. So what do we do that? That's just some exercise of creating a function, and there's a solution which is the same, and I've run it through a few different values. So 0 degrees C is 32 degrees Fahrenheit, 100 degrees C is 212 degrees Fahrenheit, and I love this one, minus 40 degrees C is minus 40 degrees Fahrenheit. So that'll just there to confuse you. Okay, so that was just an exercise to see if you're taking on how to define a function. Now I'm going to show you a few things about different ways that you can pass in parameters to a function. And it's really, even if you don't do it yourself, if you see code that does it, at least you won't be going, what are they doing? What does that even mean? So for example, if we're going to use the total seconds function, say we had our parameters in a list like this, so 1, 2, 3 being the hours, minutes and seconds. How would we pass those values into the function? Well, one thing we could do is we can refer to each value in our list using an index. So we just use square brackets and the index value. So 0 is this one here, which will be 1. 1 will be this value here, which is 2, and 2 will refer to this one, which is 3. So if we run that, we'll get total seconds of params 0, params 1, params 2 equals 3,723, which is 1 hour, 2 minutes and 3 seconds. But there's also a shorthand in Python where you can explode a list or tuple, and it'll just supply them as ordered parameters. And you do that by just putting a asterisk in front of the variable name, and it'll give you the same answer. So that's a nice shorthand to be able to use if you happen to have the data in a list like that. You don't have to split it all up. You can just supply the whole list if they're in the correct order. So second case, what if our parameters were in a dictionary? So we had seconds 1, minutes 2, hours 3. Well, we could do this. We could use named arguments. Seconds equals params seconds, hours equals params hours, minutes equals params minutes, and pass that into our function, and it will calculate 10,921, which is correct for 3 hours, 2 minutes and 1 second. But you can also explode a dictionary of parameters. And so just by putting the double asterisk in there, that says I want key names and arguments. So and those key names, it'll take that name seconds and it'll use it here for the parameter name. It'll take the hours there and use it here for the parameter name. It'll take minutes here and use it there, and comes up with the same answer. So that is quite useful. Alright, how are we going here? Oh, we've got Mexico have joined us. Fantastic. Last time we had Switzerland, so that's good to see. Now, when you're writing a function, defining a function, you can also take parameters that have been provided, like fully written out. In fact, you can't tell when you're in the function how the parameters were provided. Were they provided as star params, or were they provided fully written out like this? You can't tell. But what you can do is you can unexplode them back into dictionaries and lists, even if they weren't provided in that way in the first place. And the syntax is quite similar: single asterisk for list, double asterisk for dictionary. And so if we call a function, so this is the way we call it, unexplode is the name of the function, that could be anything, and then we provide a few ordered parameters and then a few named parameters. Fourth equals 10, fifth equals fifth. Then this will unexplode them and put them into a list and into a dictionary. And you can do, you can have one or the other or both, or obviously none, because we haven't done it this way at all up until now. But if you do mix and match, you do need to put the ordered ones first. So let's run this. And we see, so this bit of code here ran first, and it was enumerate just means give me a number for each one, and the v is the actual arguments. So v is 5, v is 6, v is 2 for the 0, 1 and second values. And then for my dictionary, keyword arguments is a dictionary, so I can loop over that using items, and that will give me a key and a value for each pair in the dictionary. And so the fourth will be a key, value will be 10. Fifth will be a key, value will be uppercase fifth. And this is how that prints out. So I just thought I'd show you that. This is useful if you want people to provide different arguments that you haven't quite defined yet, or especially if you're then calling another function, you need to pass the arguments that someone passed you off to the other function. You can collect them all into one of these dictionaries. Then you don't even need to know what the other function is arguments are that it's going to require. You just take everything in and then you just pass everything out, and it works. All right, so I hope you found that useful, and I hope you can come next week to our in-person session at AWS. If you are coming to AWS, I'd urge you to, as well as registering on Meetup, to go to our Beginners Python and Machine Learning Events app that I've just written in Django, and register that you're coming. I've got an attendee list coming here, and that way we're going to do some name tags. So I've got about half the people have actually registered the proper way doing this. The other half have only said on Meetup, so I suspect we'll be able to do name tags on the night. So, but this will certainly save us time if we can print out some name tags first. So please register on this app. All you have to do is go to the event and sign in with your Google account. That will extract your name and your email address, and that's all we need to provide to Amazon, so that they can keep track of the people who are coming onto their venue. And it's a very nice venue. They're providing pizzas as well, so it's very kind of them. It should be a good night. I'll be showing you how to write Django apps such as this one, and Arun will be doing a machine learning topic, probably on Anthropic and large language models. So are there any final questions? Hope you enjoyed it, and see you next week.